should see the activity slide 1 up. So the poll is just for me to try to get a sense of where you guys are in terms of the, working on the project. Have you started? Are you aware that there is a project? Have you done anything, towards, say, the first big deliverable, which is the memo, the status review memo? Did want to, let me let the poll go in case some more people, we've been having some people join a little late, so I'll leave it up. I wanted to do a little marketing for my other class, which is the mobile app development class. Some of you have already taken it, which is awesome. It's an elective coming up in the spring. It will be also online, so it'll have I would think a similar format to the Java class, but the mobile app class is really different because we have a completely different set of tools. It's a different language, and obviously programming for a touchscreen device is different than programming for a desktop screen-based app. But I just wanted to show you really quick kind of the tool that we've got optionally to use and how easy it is to write code and get it running on mobile apps. So the mobile app class is definitely designed for beginners. I mean, in a perfect world, I would always say if you had the choice, if you wanted to take both of my electives, take the mobile one first and then go for the Java one, because the Java one's, it's just a much more powerful, flexible language, and with that comes a good deal of complexity to master, to get good at it. But anyway, I'm going to switch to screen sharing. All right, so you should see my entire desktop now. And what I've launched is this tool that I made for the mobile development students, essentially to help them at least write some of the code, and in some cases a whole lot more than some of the code, to get their mobile apps working. So you might recognize it, actually. It is what started out as the Draw Tool app, which I created initially for the Java students to get a sense, to help them get a sense of how the order in which they drew things, the order in which they placed their draw statements in the code, how they were processed top down, and how that changed what you saw on screen. And then I realized, well, I could do a lot more. I don't have to stop at drawing stuff. If I can figure out how to do that as a first step, then there are certainly many more steps I can take. So that's where we end up with this drawn to code tool used in the mobile app class. It is pressing buttons to get stuff on screen, and then using sliders or obviously the mouse to move stuff around, and trying to think what I've got. Some text, and we can change the font and the color and all sorts of stuff pretty easily. And as we're doing this, what's interesting is the code. If we go over to the generated code, the code's being written live as we make these changes. So I don't know if you can see it, if it's zoomed in enough or not, but as I'm making changes, whoa, that's too much. The code is being written to implement those changes. And so all I'm doing is a super simple app with, say, some colors and a little bit of text. And you can position everything with the mouse, or you can get in and use the sliders, or there are keyboard shortcuts as well to center stuff. But as we're going, all the code's being written. So anytime we want to, we can test it, and it will launch it. Sorry, that's the dog groaning. Trixie. It'll launch it in the mobile device simulator that comes with the development kit. And whenever we're happy with it in the mobile device simulator, we can then test it in the official simulators for iOS and Android. And then obviously the next step would be to download it to actual devices for testing. There's fun stuff that you can do easily in the mobile app class that that's tough to do in Java. And just as an example, I'm gonna make the text invisible to start out, and then I'm gonna make it fade in slowly over. That should make it fade in dramatically. That was weird. It did, so it did do it. I'll do it again. It's being very, very slow. I'm not sure. I may be overtasking the computer, but you can see really, really pretty simply you can throw together something, and so there's all the widgets are in here too. So like if you wanted a button or a text field or whatever, you can add them, move them around, configure them, and then the code you're left with a function that contains a snippet which you can then edit to take actions that you want to take inside the button. And you can create other code using the buttons and then migrate that code into these functions to get the functionality that you want implemented. It's a really fun class. If you are interested in mobile app design or have a mobile app idea or know someone who does, I just want to let you know that it is on the books for the spring, and I would love to see you guys in class. And as Java students, you would have potentially the ability at the end of class to migrate some of the galleons that you have left over, or doubloons you have left over, sorry, now I'm already saying the wrong thing, to galleons, which is what we use in the mobile apps class. Anyway, let me stop the poll and share the results. So, and let me switch screen sharing off. Okay, so I'm hoping you see the survey results. Nothing terribly exciting, but it has ended up that the bulk of you are at you have an idea, you have a basic UI design, you're thinking about the next steps in terms of making it work, which is awesome. I think that's pretty much where I would think you should be at this point. So if you're past that, then that's excellent. If you're a little short of that, that's not a disaster at this point. There's still lots of time, but I would encourage you to dive into it with your team and start making progress. All right. Okay, so we ended up last time, we did this activity. It was a type-along activity. We added on to the team member class that we had created in chapter 10 and created a new TeamMemberPro class, which was a subclass of TeamMember. So we used inheritance to create a new class to create TeamMemberPro objects. And the key difference was that TeamMemberPro objects will have this paw prints balance or anything that you would want to add. And the code to add that to our app was super simple. We extended the team member class and we defined one attribute. And then we created a new constructor to help us create TeamMemberPro objects. And then we created a simple report by filling an array with team member objects and TeamMemberPro objects, to get a report to the console. This is a super simple app, report to the console that listed out everybody, all the students in the team, and it had their GPA and it had their paw prints balance. So very similar to the Pirate customer report worked on earlier in the book, where we had our Pirate customers and the loyalty club balance, and we created a tabular output to the console along with some calculations like averages and totals and stuff like that. So we also did look ahead a bit to next steps we wanted to take with the pizzeria point of sale. And so the idea is we want to add some features to the pizzeria point of sale that adds a product image, a status code, and a special request note to each pizza that we order. So we don't have all of the skills to do that yet, but we will get a lot of them today. The UML, just as a kind of high-level overview so that you can see where we're going, is we're going to create a Pirate Pizza subclass, and it's going to inherit from the Pizza superclass. So it'll get all non-private members of the Pizza superclass, and in addition then add this product image, status code, and special request, these attributes. It will add a method called getStatusAsString to convert an integer status code, say 2, to a status like it's in the oven or whatever is associated with 2. And then we're going to also provide a toString, which is an example of overriding, because Pirate Pizza objects will have additional information that we want to appear in the JList, such as the current status and maybe the special requests. So we may want to make changes to toString to have that more detailed information in the point of sale for Pirate Pizza objects. And again, providing the same method, the same attribute, the same object of the same name in the superclass and the subclass is referred to as overriding. So we're saying in this toString that for Pirate Pizza objects will get their own toString. Pizza objects will still run if there are pizza objects. If we created the apps that also had pizza objects, they would run this toString in their class. But Pirate Pizza objects will run the toString in their class. So overriding sounds like it's a kind of a complex object-oriented computer science term. I think it's really exactly what you would expect. If you provide something in the subclass that is a clear replacement for something that already exists in the superclass, then you're doing that because the version in the superclass is not what you want. The version in the superclass doesn't do everything you need it to do, so you're providing a replacement to override it with something that does do what you need it to do. That's overriding. And again, why override toString? Because Pirate Pizzas need a different string. And if you think back to the string for pizzas, it output the size, the crust style, the number of toppings, and a generated price. So the thing is, Pirate Pizza objects will also require those 3 things. If you think about it, they're still pizzas. They will still need to display their crust style and their toppings and their size and their price. So when writing the new toString, I mean, you could just duplicate all of that code. You could copy it from Pizza's toString method and paste it down in Pirate Pizza's toString method. But again, do you really want to do that? I mean, as soon as you start thinking about copying and pasting, you want to think, wait a minute, do I really want to copy and paste? Or is there a better way to do this? Is there not necessarily a tricky way, but just a more efficient way that will avoid having redundant code in my app to the extent possible? And so in this case, yeah, there is. The code that you want exists in the super class, and there's a keyword super, obviously the title of the slide. And we can use the keyword super to access resources in the super class. It's actually very descriptive of what we do. So if we wanted to run a method in the super class, the syntax would be keyword super dot name of the method. Likewise, to access public attributes, it would be super dot attribute to get to data that's directly in the superclass or in the superclass only. Super is the keyword to get you there. So to build our new toString, if we, for instance, just wanted to add the special request on so that it appeared in the JList next to or right after the price, we could build our string up by saying, take everything that was in the toString in the superclass, so run super.toString, which will return all of the text that we already written and we worked on formatting and tabs or whatever else we may have done in this toString. All that work's already done for us, and we can get it just by calling the method that gives it to us. And then I use string concatenation to add on to that what is new, which is I just put in square brackets the special request and close square brackets. So in the JList version, you'll see exactly what we saw before for each pizza, but then also these special requests that may be or may not be there for specific pizzas. So the keyword super is the keyword that gets us easily to access resources from the superclass directly. If you guys are on the live call, please feel free to stop or ask questions or tell me what I've forgotten or missaid. So polymorphism can be thought of in several different ways. There are different forms of polymorphism that you could talk about, but it boils down frequently to something along the lines of an object maintains its class identity. So a pizza is always a pizza, and a pirate pizza is always a pirate pizza. They don't, Java doesn't get confused and think when you create a pirate pizza and call it P2 or whatever, it doesn't later wonder, well, wait, was P2 a pizza or a pirate pizza? It doesn't wonder because the object has a class identity, and that class identity is maintained pretty much no matter what you do. Which is why Java doesn't get confused if you call a method, say, in one of the classes or one of your objects, it runs the appropriate method. It runs the method that's in the class that it belongs to. It doesn't get confused about which version, say, of toString to run, because it runs the one that's associated with the class definition for the type of this object. Yeah, again, so overloaded methods, overridden methods, they don't change the class identity. We can make changes to our objects as far along and deeply as we want to, and it doesn't change the class identity. It's not going to throw Java that you have objects from the same class that have different attributes or different names or anything else. All of these different forms that objects can take don't change the class identity that they have, is one of the basic ideas behind polymorphism. And so, long story short, it just means that Java will keep track of the class identity of your objects and run the correct and appropriate methods when you call methods on the object, even if your object is part of a complex class diagram structure. It's not going to throw Java. Scope and inheritance. So this may be where things get slightly trickier. To some extent, I think everything up until here was, things are going to work pretty much like you think. Or if you paused and reflected on how would I want this to work, everything up until here is essentially, I think, said that's going to work the way you think it should work. It's going to work the way probably you expect as you're coding it and doing this stuff. Scope and inheritance is a little trickier. So, class members labeled public in the superclass will be visible in all objects instantiated from a subclass. So, in other words, everything that's public gets passed on via inheritance from the superclass to the subclass. Your subclass will get, more broadly, anything that's non-private as part of objects created from it. That's what public means. And if you make them static, they're also available, public static, they're also available to objects created from other classes, and that's what static, or the combination of public and static means. So private. We have not used a lot of private for a variety of reasons. One of which is, when we get to this chapter, anything that was private, now you have to rethink. So I tend to wait until we get to this chapter to talk in more detail about private, and then what the implications of calling something private in a superclass is, and whether you want that, trying to help you figure out whether you want that or not. So private class members are limited in scope to the superclass only. They are not passed on via inheritance. That means if you make an attribute and declare it to be private, it is for the private use of objects created from the superclass only. It is not present in objects created from the subclass. That is essentially what private means. It means restrict this attribute to this class and or objects created from this class. Do not share it any more broadly. That's private. The problem is it's not really expected. Most people think when you use inheritance, when you use the keyword extends, or the magic word that triggers inheritance, that you get everything that's in the superclass. That's kind of what we expect from inheritance. The meaning of the word is, to give from one to another, to a child. But private violates that. Private says you get all this, but no, you don't get this. And it's hard to think of examples, great examples, where you do want something to be private in the superclass and not passed on, not accessible to objects created from the subclass. So in the past, maybe 10, 15 years ago, most of my code examples had lots of private in them because that's the best practice in object-oriented programming, is to limit scope to the extent possible. So private was considered a great way to do that. But then we would get to this chapter and then I would have to back up and say, so most of the code we've written so far is going to give us trouble because we've made all this stuff private. So that's another one of the reasons I don't privatize stuff, and I just use the default or package level access up until today when we get to this discussion. It doesn't mean the idea of private's bad. It just probably means, to me, most often, is that if I'm going to create something private, I still want it to be passed on via inheritance. In most cases, I want the subclass to get it and to be able to use it. And private doesn't let you do that. So there's one more access modifier, protected. Protected acts like public or default in terms of inheritance, and that the subclass will get protected class members, protected attributes, protected methods. But once they're in the subclass, it acts private. So it's kind of a hybrid. For inheritance purposes, it's not private, but for how it behaves then after that, in the subclass and objects created from the subclass, it acts private. And so the caution here would be, if you're creating a class and you think you might use it as a superclass, even if you're not necessarily starting out with that intention, but if you think this is a class I'm creating and I could see in the future I may need to add some features, and I'll probably use inheritance to do that for the many reasons we talked about last time, then you probably don't want to make stuff private. You probably want to make it protected. All right, the keyword final, or the process of finalization. Final is another keyword. Here's what it means. You can declare a non-private method in a class to be final, and that simply means it can't be overridden when subclassed. So if you're coding something to be a superclass, or that you anticipate being a superclass, but for whatever reason you decide this method that I've written is perfect as is, it is correct, it does the calculation that needs to be done, or it does the work that needs to be done, and I don't want to allow some other programmer to override it via inheritance, via overriding and inheritance, then you can just put the keyword final in front of it, and that means that that method can't be overridden. If you declare a class to be final, it's even one step more. Final classes cannot be subclassed. So a final class cannot be used as a superclass. So if you get to the point in your class and you think, well, this is perfect, there's no way I will ever want to use this as a superclass because it is entirely complete and perfect, and I don't want to risk some other programmer coming along and starting out with this class but then making changes to it that will inevitably cause trouble, then you can use the keyword final to essentially disallow inheritance. And then public final members will be passed to the subclass, but they can't be modified. So when you finalize something like an attribute, then you're saying that's the value. You can use it in the subclass, say in part in your calculations, but you can't change it. For instance, if we say that the overhead rate is 20%, you could finalize it in the superclass, make it public so that it can be used in the subclass and in other calculations, but you're making it so that you can't change it. It's say the overhead rate is what it is, and it's fixed. That's the keyword final. And I should say, obviously, finalization is not super common. I mean, and I would say on both of these slides, essentially when I'm talking about things, all three of these slides, that they aren't special cases, but they're things I want you to be aware of in terms of scope and inheritance, the use of the keyword private, maybe instead of using private, using protected, and then using these are ways you could use the keyword final, but again, the number of cases in which you need it is fairly small. Most of your attributes and methods will probably be package or default access or protected. They won't be private. And your use of the keyword final will be limited to cases that are really fairly special cases. When you hit a point where you say this, I don't want to allow this to be changed past this, then you could look back to the keyword final as the way to essentially inhibit inheritance in the future. And all that said, it's not my intent here to confuse you. I think for the most part, everything we do in inheritance works the way you would expect it to. And you can avoid some of the issues that we've just talked about by not using private, and worry about final if you do find yourself getting to a spot where maybe you think this is a fixed value that should not be able to be changed, then final might play a role in your code. I do have an example to try to illustrate a superclass and a subclass with elements of all of this going on. What I found the first time I tried to talk my way entirely through it, it took about a half an hour and it was terribly boring. I almost put myself to sleep. So I stopped doing that, and I'm going to kind of show you some of the highlights so that you can, if you want to, double back to this example and see how choices with respect to private and static and final and stuff work, all in one cohesive example instead of, I've given you an example of maybe static here, but an example of final somewhere else. So the SuperPizza and the SubPizza example has everything integrated together. So there's a private double price, there's a public static integer, there's a public final static double, and there's a final string get size as string. And here's the class diagram. Inside the green are the two classes. So SuperPizza is named SuperPizza. Well, I mean, clearly not. If it's our restaurant, it's not a SuperPizza. It's barely a pizza, but it is the superclass. And then SubPizza is the subclass, so it inherits from SuperPizza. And then I described just really briefly, here's the price, which is a double, a private double. And I've colored it red so that you can follow the red throughout the diagram and see what the implications are. Public static integer for the number of pizzas, it's colored white. And then final static double delivery charge, which is colored blue. And then in terms of methods, I've got one method, which is final string get size as string. And so from that, the subclass will have these accesses described as they are here and colorized. So because I privatized price, what it means is subclass objects don't have a price. So that'd be probably a bad decision there. Static int num pizzas. So the subclass also has num pizzas since it's public, and it gets one copy shared among all SubPizza objects. So it's not one copy shared among all objects. Objects created from the SuperPizza get one shared num pizzas, and objects created from the subclass get one shared num pizzas. And they could be different numbers. In terms of delivery charge, the SubPizza has the delivery charge, but since it's finalized, you can't change it. So since I finalized it in the superclass, that then impacts the subclass by making it final. You can't change it. That's what final means. Likewise, the method get size as string, which is added in the superclass, but also finalized. This is in black. The subclass has get size as string, but it cannot override it because it is final. So if you decided for whatever reason you want to have different size descriptions from subclass objects, then finalizing it in the superclass is a bad idea. And then I create objects from each type and walk you through essentially the same thing again, but what about thinking about an object, a SuperPizza object and a SubPizza object? And also in the download for the chapter, so I've got an example for you guys to run if you want to called SuperSubPizza. And it's got both of these classes exactly as specified. And then I create a super pizza called Pizza 1 and a sub pizza called Pizza 2, and I try to do a bunch of stuff with it. And I've tried to do some stuff that will not work, and I've commented that out so that you can, if you want to, thinking through this and playing around with it, you can comment these things back in and see that, no, that's going to create an error. Sorry, if I run it, sorry, that's just slightly out of the recording area, you can see I get, when you run it, it'll say something like this, pretty close to that. And if you try to comment in some of the stuff I've commented out, you'll in general get errors. And same thing down here in the subclass. I've tried to do some things in the subclass, like change the price, which you can't do because SubPizza doesn't have a price attribute because we privatized it. And you can't change the delivery charge because we finalized it. In either object, type of object. There's no syntax that would allow you to do it, is what I'm trying to show there. Any syntax you try, you might think to try, it's not going to work. It's not going to work is not because you have the syntax wrong, it's because we finalized delivery charge. So we've actually said, no, you can't change it. So there is no syntax that'll work to get you around that in some way. That's about all the time I want to spend on SuperSubPizza, just because there's a lot you can look at and play with and comment in and comment out to try to get a hang of this. But again, it's an illustration to some extent of maybe some bad decisions, like privatizing price. Probably a bad decision, and this is an example of, well, why is that? Beyond just saying it's bad, what are the implications if you were to do something like that? All right, abstract classes. This is another slightly, I don't want to say advanced, but a special case maybe. But if you'll give it a chance, it can be super helpful. So an abstract class, just by definition, is a class that's designed to be a superclass and only a superclass. So an abstract class cannot have objects instantiated from it. It can only be used to create subclasses. So it's odd because up until now, every class that we've had, its purpose was, for the most part, to create objects based on it. When we created pizza, the pizza class, we wanted to create pizza objects. When we created the customer class, we wanted to create customer objects or pirate customer objects, or whatever the case may be. We were writing classes to define these objects that we would create, their attributes, their methods, their objects, etc. That was the purpose of coding the class, was to get to objects. And yet, here's a way that we can turn that off. Essentially, we can say to a particular class, okay, you can't create objects. You can only be used as a superclass. So it may seem odd. I absolutely agree. And it definitely throws some people. And maybe another reason it throws some people is because there are errors that you can get in coding, and Eclipse will pop up with a potential fix. And sometimes one of the potential fixes is to make your class abstract. So I'll get people, emailing or asking for help, saying, I can't get this to work. What's going on? And I'll look at their code, and I can see they've picked some quick fixes that are not good. And I do see abstract a fair amount. It's almost never the quick fix that you want. I'm not sure why Eclipse does put it sometimes as the very top quick fix, which seems to imply that maybe that's the best quick fix. It's not. It almost never is. This is a very special case design decision in which you're saying, I want to create a class, but its only purpose is to make creating subclasses based on it easier and more consistent. So we're going to do this. We're going to create a class called FoodItem, which contains the elements that are common to all food items. So if you just kind of back up and think, what are the commonalities between, say, pizza and fountain drink and desserts and maybe additional subclasses, like we may have adult beverages, we may have subclasses of adult beverages, but these are all food items. They have some differences, but they also have a lot of commonality. So we're going to code food item to be essentially kind of like a master template for all food item subclasses that we're going to actually create objects from. Let's look at the class diagram. I don't go into any detail, obviously, on the subclasses, but I'm really focused on the food item superclass. Again, the idea of the food item superclass is that it will contain everything that's common to any food item that we will want to create, any subclass. So it exists in pizza, but it also exists in beverages, and it also exists in desserts. So it is those features that are common or consistent, but we put in food item that makes it easier when we create, say, pizza, because much of the code's already been defined for us in food item. But then even better, when we go to program beverage, not only is it easier because lots of the stuff has already been defined for us, but it also guarantees consistency. For instance, there's a price attribute in food item, but if we had divided up pizzas and beverages and desserts to, say, 3 different programmers or 3 different teams and said, you guys come up with the class design for each of these, you all would have come up with a price, but you might not have called it price. Sometimes people call it cost or item price or this price or food price or price double or all sorts of potential variations will pop up. Same thing with everything else. In this diagram, I called the name of the food item name, but frequently with strings, I add the $sign. And my convention is, if you picked up on it, is to do that with strings that I'm going to then convert to something else so that I can easily tell, no, this is the string version of the price, say, or of whatever it is. And then I'm going to have a double version of it later. So I want to be able to distinguish between these two, price and price string, or whatever the case may be. In any case, lots of times people get kind of used to putting the $sign at the end of the strings. And so if I had broken up pizza, beverage, and dessert to 3 different programmers or 3 different teams, the odds are pretty decent that some of you would have done it as name string or vendor string, and so on and so forth, right? What we want is some way not to allow that, to encourage or enforce a degree of consistency so that all of our objects work in a similar way. So if I want to ask for the price of the pizza, it's always going to be object.price. Same thing for the beverage. I don't have to remember, wait a minute, for beverages I called it drink price, or whatever the case may be. We want our code to be super consistent because it makes it easier to read, easier to debug, easier to code, easier to talk about with your teammates, easier to split the work up if everybody doesn't use their own terminology for everything. So that's the purpose of a food item. But what about abstract? Because you might be sitting here thinking, well, that's all well and good, but why does it have to be abstract? Couldn't I make food item just a regular class and inherit from it? Wouldn't that do the same thing? This is where it's just a design choice. You could flesh out food items so that it was a complete class that you could create food item objects from. To some extent, you want to think, would I ever create a food item object? What would that be? Is that something I would want to have appear in the point of sale? Or do I need it syntactically to get some code to work that I'm trying to get to work? Or no, not really. Food item's main goal is to start out as a starting point for classes that will create the actual objects that I need. The advantages of making it abstract are that you don't have to provide code in methods and such. You don't necessarily have to initialize values for attributes. So you just are thinking at a higher level, let's say a more abstract level, about what food items are conceptually. And then by declaring it as abstract, you then enforce subclasses to have to follow your design choices. That's what abstract does for you. And again, it may be clearer when we get to the actual point of sale and see it, but it's another one of these things. The bottom line is, if abstract is super confusing and you just don't see the point, and it makes more sense to you to make, say, food item a complete class so that you could, in some circumstance, if you wanted to create food item objects, then that's okay. That's a design decision. All right. So one of the things that we need that's a new requirement is product images. One of the three things we want to add to our point of sale, to our food items, to our pizzas, let's say, but we haven't done any work with images. That said, lots of you figured out how to use images via the Draw Tool app, and you added images to your web advertisements, which was completely fine. So working with images is not in and of itself, like impossibly complex or something, but there are a couple of issues that some of you may have run into. In the chapter downloads, I've got an app called Show Me Pizza, and when you press the Draw Pizza button, it should draw a pizza. And here's the code that underlies it. And I've kind of worked hard to pack this into the amount of screen space I had here, while also keeping it large enough, hopefully, to read. We're going to load a file using a class called image.io, and we define the file using new file syntax. So this is not something we've done. We haven't done file handling. There's an entire chapter in the book devoted to object persistence, which goes into working with files, saving and loading files and stuff. If this is something you want to dive deeper on, there's a chapter in the book that does go into that. But the syntax will work perfectly. And then to draw the image, we can actually use a method in the graphics class that we skipped called drawImage. So that's in the same class as drawLine and drawRect and drawOval and drawPolygon. It's in that same family of things, except we pass it an image object, an XY coordinate to place the image at, and then optionally a width and a height in pixels, and then what's called an image observer, or a pointer to an image observer, which is generally going to be null, however we do it. So this is kind of a little bit of a flashback in some ways. You guys might be looking at that and thinking, wow, we learned a lot of this in chapter 5, right? We're already really good at drawing, and we've made a ton of progress after chapter 5. I don't know if you guys have spent any time looking back at all the stuff we've learned so far, but we have come quite a long way from chapter 5. And I don't want it to think like I'm dragging you backwards or anything. It's a new skill we're adding, but it is using syntax and stuff that we did cover quite a while ago now. I should also say there are different ways to make images appear in your UI. Using the graphics object and draw image is only one of them. I don't mean to tease you by not telling you, but different way off the top of my head would be, well, first off, you could obviously use this as part of a custom panel. You could put the image in the paint component, but you're still using draw image then. Even if you use a custom panel, you would still be using draw image. The other common way to do it is you can set, I'm sorry that the dog just wedged herself under my feet. Made me lose my train of thought. Labels, yeah, labels. You can add an image to a label instead of text. That's a super easy way to get an image in your UI, and it has some advantages that I go into in the GUI chapter, which is another chapter in the book for you to dig into if you want to learn how to do more stuff. So if you're looking to put images easily into your, say, your point of sale, but you really don't want to use this draw image approach, know that you can attach images to labels and also to buttons. So if you wanted something like a button that had an image on it of some sort, either instead of text or in addition to text, you can do that, and much of that is going to be covered in that GUI chapter in the textbook. Anyway, that was a bit of a tangent. I do want to not skip over this. One of the problems people have doing images is it's a little bit unclear in Eclipse where you should put the image, where you should put the file itself. So for instance, if I have this pizza.ping or pepperonipizza.ping file, I know I need to move it into Eclipse, but there's different places I can drop it. And so that's one of the things that trips people up, is they put it in the wrong place. So in general, if you're using the syntax I'm giving you or the syntax the draw tool writes, you're going to put the ping in the project folder, not in the source folder, but in the project folder. If for whatever reason you don't want to put it there are certainly different syntaxes. And in addition, you could put it in subfolders. So you could create an images folder and put stuff in subfolders if you wanted to organize your workspace in that way. That's totally doable. And you just prepend this with the folder. So images / pepperoni pizza if you put it in the images folder. So I have a little activity. I give you the pirate ship red image, and the activity is just to create an app that draws the pirate ship. Let's jump over to Eclipse and do this activity together. So if you're live and want to try to get ahead of me, that's what I'm going to be doing. If you're watching the video, then, well, same thing. You can, if you don't have Eclipse open, fire it up, and we're going to make this app. So I'm going to zoom over to screen share. You should see my Eclipse. I already have the pirate ship red image in my project folder. Just as an illustration, here's what's confusing, is you can drop it on the project folder or the source folder. If you drop it in the source folder, it still looks like it's in your project, but the syntax we're using will not find it. So instead, I'm dropping it on the project folder. I've called this project chapter 11, just because that's the chapter we're working with. So I want to create a new app in chapter 11. So I will say new class, and I'll call it pirate ship. It does need a main method, so I'm going to pick that. I'm going to hit finish. I'll zoom in, and then I want to do the basic stuff I need to do to create a GUI app. So it's going to extend from JFrame. I want to create the app. I'll want to reorganize imports constantly. I want to set the size. Doesn't really matter. Oh, that matters. Set default close operation, and then show or set visible. And then I need a constructor. All right, so all I've done, and you might have done this quicker than me, I'm not all that fast, but I've set up this basic app framework or template that we've used now for months to create all of our apps. I don't think it's anything fancy. I do need a panel to draw on. You can make a custom panel, a subclass of panel, and put the drawing of the pirate ship in there. That would mean we don't need the button. So since the chapter is inheritance, why don't I do that? Because that does use inheritance. So I need a class called, I'm going to call it ShipPanel, and it extends JPanel. Reorganize imports, and I need public void paint component graphics G. Redo imports. So I need to load the image and then draw the image. So let's start with loading the image. Let me see, I don't think I can arrange it so everything's on screen at once, but I'm going to give it a try. So we're going to use a class called BufferedImage, and then to load the buffered image, we're going to use imageio.read. The only thing that makes it slightly more complex is when you do IO read, you have to put this in what's called a try-catch block. But Eclipse is going to write this for us, which is what I'm going to show you once we get going. So I need the PirateShip class, so it's buffered image ship image, maybe. Reorganize imports, and then I want to load the file. And most of this kind of work I normally do in the constructors, so I'm going to continue this in the constructor. So it's a ship image equals image io dot read file, and then it's new file, and then reorganizing import. I want Java IO file for sure, and then the name of the file, which is over here, pirateshipred.ping. Okay, but if you're following along and typing, what you'll see is, yeah, this does match what I said I needed, but there's still an error, and the error is that we need to surround this with a try-catch. So if we hover over it, let's read the error. It says there's an unhandled exception type IO exception. And there's two quick fixes, but the one you want is the second one, surround with try-catch. And you can see Eclipse just rewrote it and placed the try-catch in place. So it now looks more like the example in the keynote. So that should load the image, but we still have to display the image. So we display the image. I've moved down to paint component, and we'll say g.drawImage, ship image. We'll put it at 0, 0, and I don't need any of the rest of these except for the observer. We may need other stuff, but I'll come back and show you when we add it. So again, null is fine. X and Y here are the top left corner of the image. I left off the width and the height, so let's run it and see what we get. If you leave off the width and the height, what you'll get is, all right, I'm not seeing the pirate ship, and I'm not getting an error. So, oh, okay, yeah, I'm being an idiot. If you're following along, I skipped a step. I've defined the ShipPanel class. I have it set up to draw the image. I load the image, but I haven't added anything to my UI. So in addition to the buffered image, I need the JPanel. So I need a ShipPanel, whatever, P equals new ShipPanel. And then in my constructor, I need to add the panel to the UI. Since I'm not doing the button, I don't have to say put it in the center region. I can just add it. I think that should get me where I need to go. There we go. All right. Obviously, there's a working example essentially like this with Show Me Pizza, which is in the download for the chapter. But the activity was to get this pirate ship example working, and it's as long as you remember all the steps, it's pretty easy to do. I don't know that I made it look easy this time, but it is. And so you would resize the image here to whatever you wanted, or leave those numbers off to get whatever the default pixel resolution size of the actual image is. But frequently, the images need to be resized to fit it. You can't do that if you add the image to, say, a J label or a J button. So you either have to make the images the correct size first, if you're going to use it in a J label or a J button, or you have to take an extra step, which is create a resized version of the image, which is also relatively easy. So that's what is activity 2. So we're just about out of time, but I want to give you a preview of what we're going to do next time. So we're going to add the product image, we're going to add the special request, we're going to add the integer status code. These are going to go in this new PiratePizza subclass. We're going to extend the constructor so everything's properly initialized, and we're going to override the toString to give us the extra information that goes along with PiratePizza pizzas. So the syntax is right here, and it's the exact syntax we've been working with, which is PiratePizza is a subclass of pizza. So we say public class PiratePizza extends pizza. Here's the three new attributes. I'm using an image icon because in this example, I'm actually going to put it into a dialog box, which I didn't mention. That's another way you can display images. So the dialog box expects a variation of an image called an image icon. And I actually have done the code here to resize it so that it fits nicely on or inside of a pop-up dialog box. But the new constructor calls the superclasses constructor using this super syntax. And then I initialize additionally the other attributes. So special request is set equal to essentially nothing. I put 2 hyphens there so that in the UI you see two hyphens so that I know that it was initialized. If you don't see anything, there's always the chance that I forgot to initialize it. So in most of the stuff I do, I want to see that I did successfully initialize it before I set it to something actually meaningful. Status code set to 0. The pepperoni pizza image is loaded in and then resized. So that initializes product image status and special request. That's all this code is doing. And then I've added on to the toString exactly like I said earlier. I call the superclasses toString to get the size, the crust style, and the toppings and the price. And then I append on the end to that the special request text in square brackets. So let me run it so that you guys get a preview before we quit for the day. So Pizzeria Point of Sale 3 has a very similar interface, but as I add pizzas, what you may notice is I added 5 pizzas by hitting the Add Pizza button 5 times. These are totally random again, and you can see that they've got the square braces with a double hyphen in them, which is what shows me, okay, I did initialize special request correctly. If I want to make the special request something different, I can just select the pizza and add it, and it will show up now in the point of sale as the special request. We'll get to this next time. I just wanted to give you a preview. You should see the keynote, the notes keynote. If people get confused, it's that they see in PiratePizza, I've only declared 3 attributes. So if we go back, so PiratePizza has just got special request status and product image. It doesn't have price. It doesn't have crust style. It doesn't have size. Or at least it appears that it doesn't because they're not listed here. But they're there because we get all of that from the superclass. We get size, we get crust style, we get toppings, we get price, we get all the get methods. Everything that's not private, and there was nothing private, PiratePizza gets as part of its inheritance. So don't let it confuse you that PiratePizza actually seems maybe to be too simple, because it is simple, but the simplicity comes from the fact that we're leveraging work that we did earlier. We're leveraging code that we've already written. We're leveraging the power of object orientation. So we will pick up next time here, and go into detail on how to get this image icon to work, and then we're done with inheritance. Thursdays, Lab Day 3, Homework Check 3. So we'll do the same kind of thing we did last time. If you guys want to do a follow along, I'll do a follow along. Otherwise, you can zip up your Eclipse workspace and send it to me. That's what I wanted to cover to get through today. So I'll see you guys on Thursday. If you can join into the live follow along, or do the recorded follow along later, or send me your Eclipse workspace, it's all good. If there are any questions, If you're on the live call and that's all you wanted, then obviously you are dismissed.